Hello again. So for this video, I'll be discussing about circle theorems with focus on finding arc length, sector area, and area of a segment. Okay, so let us have length of an arc. So the length of an arc of a circle can be determined by using the formula. Arc length is equal to degree measure of the arc all over 360 times 2 pi r. So let us have an example. So find the length of arc MN. So take a look at the given figure. Here we have circle A with radius 12 centimeter and a degree measure for arc MN is 75 degrees. So let us follow the given formula for arc length. So arc length, okay. So arc length is equal to, so the degree measure of arc MN is 75 degrees. So we will have 75 all over 360 times 2 pi r. So I'll be keeping pi first. I won't be changing it to fraction or decimal yet. And then for radius, it's 12. Okay, so let's simplify. We can simplify 75 over 360 is divisible by 15. So this would be 5. And this would be 24. Now we have 2 and 12, that is 24, so we can completely cancel out 24 here. So we will be left with 5 and pi. So therefore, the arc length, the length of arc MN is 5 pi centimeter. Now, if we can just keep our answer in this form, unless otherwise your teacher requires you to change your pi to 22 over 7 or to 3.14. Otherwise, this is okay. Okay, let's have the next one. So, area of a sector. The area of a sector of a circle can be determined using the formula. Sector area is equal to degree measure of the arc all over 360 times pi r square. As you can see, the formula is similar with finding arc length. The only difference will be that we will multiply it with pi r square since we are talking about area, right? And the area of a circle is equal to pi r square. So let us apply that formula. So I'll be using here the same figure from the previous example, but we will be finding the area of sector MAN. So if we look at this figure, this is what we are looking for, this sector. Okay, so we are looking for the area of sector MAN. So let's follow the given formula. So we have sector area of MAN is equal to degree measure. Still, it's 75, of course, all over 360 times, I'll be keeping pi again in this form, and then our radius is 12, and then let's square it. So simplifying, the same thing as the previous one, this would be 5 and this would be 24. Now we can also cancel out one of the 12 here, so we'll only have 112 left, and this would be 2, and then we can simplify further. 2 and 12, this would be 6. So 5 times 6, that is 30 pi. And our unit is square centimeter. So the area of sector MAN is equal to 30 pi square centimeter. Okay, let's have now segment of a circle. So the region bounded by an arc and the segment joining it. endpoints. So let's take a look at the given figure here. Let's name some of the points first. Okay, let's say this is circle A. Then let's name this as B and C. Okay, now the segment of a circle that we are talking about here is this part. Okay. Okay, so that red part there is what we call as a segment. As you can see, it is bounded by an arc, that is arc BC, and of course the same thing, the chord BC. Okay, and that's our segment there. Now, if we want to solve for the area of a segment, so the area of a segment can be determined using the formula sector area minus area of triangle. So if we look at the given figure here, we have here, we can solve first for sector area BAC, and then after that we can solve for the area of triangle BAC. If we subtract it to sector area, of course, we will be left with the area of this given segment here. Okay, so let us apply it. Let us solve some problems. Okay, let's have an example. Find the area of the shaded segment. So we have here a circle with a radius of 8 centimeter, and we can also see that we have a central angle which is a right angle. Therefore, the measure of the intercepted arc is 90 degrees. Okay, then okay, so let's solve. So if you remember the formula that that I have just shown you a while ago, which is sector area minus area of a triangle. So we will follow this one. So let's start. So to solve for sector area, we need to have, again, let's recall, degree measure of the arc divided by 360. So the degree measure of the arc here is 90, since it's a right angle, over 360 times pi r square. Now for pi, this time I will change pi to 3.14. You can also use 22 over 7 if you want to. And then for the radius, we have 8. So that would be pi r squared. So we need to square 8. Then minus area of a triangle. So we have here a right triangle. So it's easy to solve for its area, which is 1/2 times the base and the height. Since the base and the height of the given triangle here is the radius of the circle, so it will be the same. So you will have 8 times 8. So let's simplify 90 over 360. This is, of course, 1/4. Then let's multiply to 3.14 and 264. If we do that one, we will get 50.24. And then, of course, here 1/2 times 8 times 8. We can cancel out 2, and then 8 will become 4. So 4 times 8, that is 32. Then 50.24 minus 32 is 18.24. And the unit is, of course, square centimeter. So the area of the segment we are looking for is 18.24 square centimeter. Okay, let's have the second example. So in the given figure, AB is equal to 24, BC is equal to 7 centimeter, and L is the center of the circle. Find the area of the shaded region. So we'll be using 3.14 for pi. Okay, now Instead of using the formula for the area of a segment, I think it would be easier to just solve this by finding the area of, as you can see, the triangle here and the segment covers half the circle. So it's a semicircle. So if we find the area of the semicircle and then we subtract the area covered by the triangle, we will end up finding the area of the shaded version. So let us do that one. So first, let us find the area of the triangle here. As you can see, angle ABC here intercepted a semicircle. So therefore, angle ABC is a right angle. Okay. Now, we can go straight solving for the area of this triangle. Let's mark the given here. I forgot. So AB is 24 and then BC is 7. Okay. So if we solve for the area of the triangle, that would be equal to 1/2. And then our base is 7. And then the height is 24. So this is 2 and 24. We can divide by 2. This will become 12. So we will have 7 times 12, which is 84 square centimeter. So we now have the area of the triangle here, which is 84. Now, let us find the area of a semicircle. So we know that the formula for solving the area for a whole circle is pi r squared, right? But since we're looking for the area of just half of it, so we will have pi r squared divided by 2. Now, before we go straight solving for this, as we can see, we still don't have the radius of the circle. But since we have here a right angle, we can just use Pythagorean theorem. So since AB is 24 and then BC is 7, so AC here is our hypotenuse. So by Pythagorean theorem, if we solve this, we can find that AC is equal to 25. Okay, so the diameter of the circle is 25. So therefore, our radius is half of that, which is 12.5. Okay, so let's go straight solving for the area of the semicircle. So for pi, again, we will be using 3.14 times the radius of the circle is 12.5 square divided by 2. So if we solve this one, we will have approximately 245 point, let's use one decimal place, 245.3. Okay, now we have the area of the semicircle and then the area of the triangle. So to solve for the area of the shaded region, so we will subtract the area of the triangle from the area of the semicircle. Okay, let's do that one. So we will have 245.3 minus area of the triangle is 84. So we will have 161.3 square centimeter, and that's the area of the shaded region. Okay, let's have the third example. So a sector of a circle has an intercepted arc of 144 degrees. The area of the sector is 22.5 pi square centimeters. What is the radius of the circle? So this time we are given um, the area of the given sector plus the degree measure of the arc, and we need to find the radius of the circle. So we can just substitute all the given here to the formula, and then we can find the measure of its radius. So let's do that one. Okay, so we're given the sector area, which is 22.5 pi. So let's substitute that one. 22.5 pi is equal to, degree measure of the arc here is 144 all over 360 times pi, and then we are looking for radius, so we can just write r square. Okay, let's cross multiply 360, 22.5 times 360, and that is 8,100 pi. Okay, and then on the right side we'll be left with 144 pi r square. So we both have pi on both sides, so we can cancel that one out, and we'll be left with 8,100 is equal to 144 r square. So let's divide both sides by 144. So we will only have r square on the right side, and then 8,100 divided by 144. So if we simplify this one, we will have 225 over 4. So r square, let's continue here, is equal to 225 all over 4. Now to get the value of r, let's get the square root of both sides of our equation. So we can cancel out this, and we will only have an r. So square root of 225 is 15, and then square root of 4 is 2. So our radius is 15 over 2, or 7.5. Are we given? Okay, centimeter. Okay, let's have the last example. So we have four congruent circles are described about the four corners of a square so that each other touches two of the other circles. If each of the side of the square measures 14 centimeter, what is the area and perimeter of the shaded region? So we're looking for this part here, the shaded part here. So we need to find the area and perimeter of the shaded region. Okay, so we are given the length of the side of the square, which is 14 centimeters. So it's all 14 on all sides. It's square. So if we have that one, it means that the radius of the circle is 7. Okay. So we have 7 and 7 is 14, right? So they are congruent circles. So meaning the radius of all our circles here is 7 centimeter. Okay. Now let us solve first for area. Let's do area first. So if we want to find the area of the shaded region, if we analyze the given figure here, we have a square, so we can get the area of the square first, and then after that we will subtract the area of the four sectors. Okay, the sectors that I'm talking about is this one here. This is our sector 1, sector 2, sector 3, and sector 4. Okay, take note that this is a square, so therefore all its angle is a right angle. Okay. Oops. Okay, so we all have a right angle there. So if we think about it, we have four sectors. They are all right angle. So if we put them together, okay, if we put together all the four sectors, we form a one whole circle. Since all the sectors are equal, there are four from a congruent circles, right? So here's what we will do. We will find first the area of the square, and then we will subtract the area of a circle. Again, we do that because we have four congruent sectors, which when put together covers one whole circle. Okay, so let us have first the area of the square. So the area of our square here, of course, so the measure of the side of the square is 14, so that is 14 times 14, or 14 square, which is equal to 196 square centimeter. Now for the area, again, instead of solving for separate sectors, we can just find the area of a whole circle, and our formula for that is pi r square. So for pi, this time I'll be using 22 over 7. So pi, and then our radius is 7. Then let's square it. Okay, so if we solve that one, we can cancel out 7 and 7 here. So we'll be left with 22 times 7, which is 154 square centimeter. So now to solve for the area of our shaded region, so that would be equal to the area of the square minus the area of the circle. So that is 196 minus 154, which is 42 square centimeter. So now we got the area of the shaded region. So let us solve for the perimeter of the shaded region. So this is what we are looking for. Let's put a line on it so you can see it easier. Oh, it's not so. Okay. Okay. So we will find the perimeter of the shaded region, right? So we are going to find these lines here all together. Okay. Now, as you can see, okay, the perimeter we are looking for are the combination of the arc lengths of the four sectors we have here of S1, the one we have marked a while ago, S1, S2, S3, and S4. So what we will do is we will just find the arc length of one of the sector, since the circles are congruent, right? So once we got the arc length of one sector, we can just multiply it by 4, and then that would be the perimeter of our shaded region. So let's solve for the arc length of one sector. So if you can remember, the formula for arc length is equal to the degree of the arc. So we have here a right angle, so that would be 90 all over 360. Then you need to multiply it to 2 pi r. Okay, so let's multiply to 2, oops, 2, and then for pi, let's use 22 over 7. And then our radius is 7. Okay, now you can use 3.14. It's just that I see that the radius is 7, and since we have the denominator of 7 for 22 over 7, we can cancel it out. That's why I chose 22 over 7 for it. Okay, so let's simplify. 90 over 360, of course, this is 1/4. And then we can cancel out 7 and 7 here. Okay, let's rewrite 2. Okay, so now we will have 44 divided by 4, so that would be 11 centimeter. Again, this is the arc length of just one part here from one sector. So if we want to get the perimeter of the shaded region, we need to multiply it by 4. Okay, so therefore the perimeter is 44 centimeter. Okay, so that's it for this topic. I hope you learned something. I think I still have some more videos to upload for circle theorems. Hope you watch for it. Again, thank you for watching. Bye.